Okay, as I told you, today we will be discussing on decision theories. Now, just give you a brief, as you know, in our day-to-day life, everyone, whether it's you or me or anyone in the case, everyone makes some decision or the other. Now, these decisions are based on different, you can say, theories. Sometimes decisions are made casually without thinking. Sometimes you analyze the data which is available to you, might be the data which is available in form of opinion from others, and then you can make a decision. For example, let's suppose if you want to go for a movie, so either you will refer to the reviews which are published in the newspapers or the magazines, or online you might go online and decide whether you would like to go for that movie or not, or might be some input you take from the your friends, okay, and then you can make a decision. Or some decisions are based where you decide for today's example. Let's take a very simple example, whether you would like to attend a particular lecture or not. So that is depending on your mood whether you would like to do it. So it is not based on any input as such. Okay. Now, if there are some decisions which are very serious type of decisions, for example, investments, or let us say you are a manager of a company and you have to decide whether you should launch a particular product or not. There are different options are available to you, different alternatives available to you. Now, in such case, what you are going to do is you will do some study based on, say, data which is available, data which is, of course, which is relevant to the products or to the market, and then you will come up with some decision. Again, when we say key, you'll be coming up with the decisions, you will be doing some calculations as well. Calculation in the sense of like whether this product is really going to give some profits or a better profit compared to the other product as well. There are many things. Let us say you want to invest in a stock in the stock market, and based on the news channels, the magazines, or your you can say fundamental analysis or might be technical analysis. You follow some charts or something like that, and after studying all this, you will make a decision whether I should invest in a particular stock or not. So basically, you'll find that in our day-to-day life, we keep on making decisions, knowingly, unknowingly, based on some data. We are always, analyzing data in our mind, might be not on paper, and then we go ahead and take some decision. Okay, so you can say that decision making is a process where we are actually selecting from a set of alternatives which we have. So if, for example, the first example which I gave you, if I want to go for a movie, might be I have two, three movies as alternatives, and then based on my, analysis or feedback or the reviews, I might decide to go and watch a particular movie. So basically, this alternative, picking up the alternative, is nothing but making a decision. Okay, but it is not that keen. Again, the example which I gave was a very simple example. But when we talk about industry, when we talk about organizations where lots of money is at stake, so making decision becomes very critical. Okay, now it can happen that when you are making a decision, you might have some information which can help me make a decision, or the other way around, it might be happening that this is the first time you have come across such problem, and then you are supposed to make a decision where there is no input available, no information available. Okay, so there are different types of environment, you can say, or state of nature in which you have to make a particular decision. It can be a decision which is made under risk, where there is lots of risk of losing your money, or decision which is made under uncertainty. Uncertainty in the case we do not know how the market is going to behave. For example, if uh, the stock market itself. If suppose today the market is in a bull run and I'm investing in it, but suddenly things might change. The environment might change. The stock market might fall because it's at all-time high. Okay, so this is uncertainty, you can call it. Might be we are not aware what is going to happen, but due to the previous data, the previous information which is available, might be we can make a proper decision. Sometimes we rely on the probability of the market. Let us say the probability of the market going down is more compared to going up. Then we decide not to invest or not to buy. In fact, we'll go ahead with sell or something like that. Okay, so basically you will find decision making and decision theories. There are different types of models available, which we are going to learn. There are basically two things or two models which we are going to cover. We are going to cover decision making under risk and decision making under uncertainty. Okay, these are two models. Let us see the introduction part, what we have in the PowerPoint right now. So let us see some definitions. The topics which we will be covering in this session will be some introduction, which briefly I've already given you, and then the elements of decision making, then decision models. There are basically four models. We are not going to cover all the four models. In the syllabus, we are going to cover only decision making under risk and decision making under uncertainty. Let us look at the introduction. Now, if I look at the definition, we say that decision making is a process of selecting from a set of alternative course of actions, okay, which best meets the objective of the decision problem. Okay, so depending on the objective, we might select the alternative which is best suiting me or which will give me the best result. In decision-making process, we have various alternatives which are developed, and it is based on the available data. Please remember, if data is not available, it means it is, you can say, decision-making under uncertainty, or might be, sometimes what happens based on the experience of the manager, of the person, they might go ahead with some decision. Okay, it's totally based on, sometimes it is based on intuition. Okay, so intuitive or previous experience that helps in making decision as well. Or if the data are available, then proper analysis of the data can help me make a proper decision. Now these are then the process or the alternatives. Alternatives are actually weighted logically and empirically as far as possible and feasible before selecting the best alternative among them. So this is how we are going to go ahead and make some decisions. Of course, there are some models which are available, which we are going to follow depending on different scenarios. Now, what are the different steps which are involved in decision-making process? First of all, we should identify the problem which we need to solve. So the first step would be to identify the problem to be solved. Second, we should know or we should define the objectives. So defining the objective sought by the solution of the problem. Then collecting the relevant data. Here we are focusing more, or I highlight the keyword relevant data, because if the data is not relevant, you are not going to come up with the proper decision. Okay, so data, you can see this step of decision making process is the most important step, collection of relevant data. Then comes developing the various alternatives for solving the problem. Once we get all these alternatives, we need to perform the evaluation using a suitable criteria. So the next step would be evaluation of these alternatives in light of the solution objective using a suitable criterion. And then finally, selecting the best alternative and implementing it. Okay, now you'll find this decision-making process. It's nothing but these are some methods which are available, which are quantitative in nature. So we use quantitative methods to make decision. For example, we can take an example of, let us say, break-even analysis of to decide the production level. It's a simple example of decision making. Or let us say if I have something like a forecasting, some forecasting technique used in sales forecasting, or even the movement of a particular stock. So forecasting, and you'll also find there are many automate programs available or ERPs available which help me in making decisions. So especially like for example, again your inventory management system, which will help me decide how to handle my inventory and so on. Okay, there are some elements which are involved in decision making problems we should be aware of. Let us look at those elements. The first element is the simplest one is your decision maker. So who's a decision maker? You, me, an individual, you can say, or a group of people or individuals who make the decisions will be known as your decision maker. Then comes your strategies, or you can call it as course of actions. Now, these are the various options available to the decision maker for solving the problem. For I've just taken one simple example: minimum inventory to be stocked for the sale of a commodity in a given period of time. So it is represented by variables like S1, S2, and so on. So let us say a simple example here is S1, where strategy of stocking 15 units, and S2 is strategy of stocking 20 units. You can have many such strategies. Just a simple example. Like if I take an example of the stock market, then the strategy might be whether I would like to invest in equity or debt, mutual funds or gold and so on. So it's a part of the investment strategy. Now, what about the other element? The other element is the state of nature or the outcome. So depending on the state of nature, I might decide whether I should go for a particular strategy or not. Let us say the stock market, the bullish market. Under bullish market, I should go for buy. If it is bearish, I will go for sell. If it is flat, might be I will stay away from the market and try to invest in some commodity like gold, where I find that there is some steady return coming in. Okay, so state of nature is represented by the variable n, and it is like n1, n2, and so on. So these are the events which indicate the occurrences which are not under the decision maker's control. Remember, whether the market is bullish or bearish does not it is not controlled by a decision maker. So based on that, you can say the state of nature, one person or the person has to, or the individual has to make a decision, provided he does some proper study of the data and all. Okay. Now the example, if I continue with the previous example of S1 and S2. Now again, the market demand, depending on the market demand for a commodity during a given period, I can have, say, the market demand is of 15 units. That becomes my N1, which is the state of nature. Similarly, I can have N2, which is the market demand of 20 units, and so on. Okay, these are just basic, or we can say very simple examples which I have quoted here. Then the other element is your payoff. Payoff is, you might have seen payoffs in the previous units or chapters as well. So your payoff will be nothing but the combination of your course of action, that is your strategy, and state of nature with a particular amount, or might be a gain or a loss. In case of cost, it is considered as negative value. In terms of profit, it is a gain. Okay. Sometimes it is also known as conditional payoff. Clear? Now, all this, the example which I have taken here might be like, for example, S1N1 in the previous one. Say the market demand of 15 units would be around 50 rupees. And this is just an example. Now, all this payoffs together can form a payoff table. So it is a set of payoffs for the given strategies, along with all the state of natures, that is your outcomes, that are mutually exclusive. When I say mutually exclusive, I want to say both of them cannot occur simultaneously. That means the state of nature. You cannot say the market is bullish and bearish at the same time. It's not possible. So either one of the state of the nature will occur. and it is collectively exhaustive. I The meaning of collective exhaustive here is that at least one of the state of nature or the outcomes will definitely occur. Okay, so either the market will be bullish or bearish. Okay, you cannot say neither of, or if I have the third state that is flat. Okay, so we can say either one of the state of nature will definitely occur when we call it as collectively exhaustive. Okay, the example, the table looks like this. So this is just a example of your payoff table, where you can see the row headings which we have given S1, S2, S3, and so on up to SM. These are your strategies. You can always see that in some cases, while giving you the problems, they might give you the strategy as the column heading, but you need to put the strategies. You have to rewrite the strategies so that they are, in the first column itself, and they become the index of your, you can say, rows. So S1, S2, and up to SM will be your strategies, whereas your N1, N2 up to NN is your state of nature. Now, sometimes you might get the probability of states as well, where P1, P2 up to Pn is given. In some cases, probability is not known to us, especially in case of uncertainty. So this probability will not be given. Okay. Whereas I think in cases like under risk, under certainty, probability is definitely given to you. And if I want to find out the payoff of a particular value, that is x11 represents 1, 1, that is x11 represents this value, it represents the payoff. And if probabilities is given, so P1 multiplied by x11 will give me the actual value. Okay, let us go further. Now, the weighted payoff associated with a given strategy state combination, as I told you, will be, P1 multiplied by X1 if I want to find for S1, N1. So for example, like in the above table, weighted payoff for S1, N1 combination will be equal to P1 multiplied by X11. Okay, it's okay. Coming to the next topic, with is decision models. As I said, decision theory is actually concerned with making optimal choice. Okay, so if I have to make a choice from my alternatives which are available, it should be the optimal choice from the given, you can say, set of alternatives or strategies as well. There are basically four models for decision making, which is as follows. We can say the first one is decision making under certainty, where the consequences of each course of action are certainly known and there is only one state of nature. So if we are aware what is going to happen and also whatever decision we are making, I think we will be making the best of the decisions. Okay. Second one is decision making under risk, where there are several states of nature and the probabilities of occurrence of each state are known to us. Okay. And like in the previous table, which I showed you, the payoff table, where the probability of the state is also given to you. So that type of a table will be available or given to you under, say, this is when you're solving the problem based on decision making under risk. The third one is decision making under uncertainty, where the probability of occurrence of different state of nature are not known. Okay, so probability will not be given. We do not know the probability because might be the past records are not available, or might be it is the first time you're doing some or you're solving some problem. In such cases, the decision making under uncertainty will call it that the probabilities of occurrences will not be available to you. And the last one is decision making under conflict. Okay, we are not going to discuss much about this. Might be this will come in game theory when we actually look at the strategies where two different players are competing with each other. Right now in the syllabus, we are going to just discuss two topics here. decision making under risk, and decision making under uncertainty. That's the two models which are part of your syllabus. Let us go ahead and check decision making under risk first. Now, in this situation, as I told you, the decision maker is aware of all the possible states of nature, but does not know their occurrence with certainty. Okay. Thus, we know that the probabilities are given to you, as we can see. So, is not aware, you can say. Thus, we know that or can just estimate the probabilities of occurrences given. And this is based on this past experience or on the theoretical probability distribution of the state. Now, to solve such problems, we are going to use a particular criteria. The first criteria which we are going to use, especially when we are making decision under risk, is known as your expected monetary value criteria. So let us see that. So what is this criteria? The decision under this situation is taken on the basis of your expected payoffs. Okay, and in short, it is known as expected monetary value, or EMV, which is calculated for each strategy. Now, EMV represents the long-term gain to be expected from a strategy if the decision is repeated large number of times. Thus, for a payoff table, again representing gain, we can follow the steps which I'm going to show you now. So we can go ahead with the following steps when we have to do the calculation for EMV, or expected monetary value. Please note down the steps which we'll be using to do the calculations. So the first step would be, for each strategy, we are supposed to calculate the EMV using the following function. This is my function, EMV equal to sigma, or you can say summation of all the weighted payoffs. Okay. So if I have the strategy SI, for SI, the formulas, that is EMV of SI, will be equal to summation of, you can say, for value j equal to 1 up to n, pj, that's your probability, multiplied by x1j. Okay. So when I'm talking about 1j, that means I'm talking about the first strategy, okay, or the first row, you can say. Right? If I have S1 here, the formula will look like this. Okay. So we have to find out the EMV for S1, S2, S3 up to Sn, whatever the number of strategy I have. Okay. That is my first step. Once we calculate the EMV for all the strategies, okay, we have to identify the maximum EMV. Okay. So identify the maximum EMV among all these EMV values which we have calculated, which is very simple. Again, going to the next step is the strategy corresponding to the largest EMV, or the biggest value, the maximum value, will be my optimum strategy. Okay, it's a very simple one, right? So that's my third step. The strategy corresponding to the largest EMV is my optimal strategy. Second one is finding the expected value with perfect information. If the decision maker has perfect information about the state before he makes a decision or he takes a decision, he can select the best strategy, okay, giving you the maximum payoff for each of the states, you can say. Now, this gives the expected value with perfect information. So what we can do is, while doing the calculation, we can take the best strategy by taking the maximum payoffs for each strategy and multiplying that by the probability. So if I have the information, what I can do is, for a particular strategy, I can take the probability, multiply by the payoff, the maximum value, and we can get the result. And we'll see one example on based on this as well. The third one is value of perfect information, because if information is available to you, definitely it has to be, some paid information. You have to pay for the information. Now, while doing the calculation for VPI or value of perfect information. It is the formula is the expected value with perfect information minus the maximum of EMV. That gives you the uh, answer for value of perfect information. That is your VPI. Let's take a example and you will understand it much better. So to take an example, we have a major consumer good manufacturer. It wishes to decide which of the two new products to bring out in the market and what level of advertising to use. The profit tables for these products are given as follows. So there are two products here. We have Ozone and Life are the two products. Okay, and we have been given there are three strategies here where we have S1 high, there's a demand. So high demand, S1, average and low. We also have A1, A2, and this A1, A2 is nothing but where A1 stands for low expenditure advertising program. So these are my course of actions, you can say, which action should I take? A2 is your medium expenditure advertising program, and A3 represents your high expenditure advertisement program. Okay. We also have been given the uh, probability distribution for the demands. So they are given like this. I want you all to please note this down. I hope you have taken it down. Just take a screenshot of this. Second one is that they have provided us the prior probability distribution for the demand. It's like this for S1, S2, and S3 based on the products. For ozone, for S1 it is 0.4, for S2 it is 0.5, and for S3 it is 0.1. Similarly, for the product life, we have been given 0.2, 0.2, and 0.6. Now, there are basically two questions which are asked. So, which product and advertising level would you recommend from the given information? And secondly, what is the expected value of perfect information for each product? Now, to solve this problem, here we have S1, S2, and S3 actually represent the same state of nature. Okay, they are not strategies. You know, it is very confusing when they use the character S there. So immediately what you will feel that is S1, S2, S3 are not your strategies, but please remember, they are not strategies, they are state of nature. Okay. So please read the problem before you come to the conclusion, what is strategies and which are the state of nature. In this case, A1, A2, A3 are the strategies. That means whether I should go for a low expenditure advertising program or a medium expenditure advertising program or the high expenditure advertising program. These are my strategy or the state of nature. Sorry, your strategies or the outcomes. State of natures are S1, S2, and S3. So because they are not given in the proper format, I will be rewriting this whole table. So to rewrite this, I'm going to come up with a table like this. So this is my new table and the calculations. So what I've done, I've put the strategies here, A1, A2, A3. These are my state of nature, and I've also written the probability here. You can see 0 0.4, 0 0.5, and 0.1. This is for my product ozone. These are my payoffs which are given to you. So 140, I've rewritten it in the proper order. 140, 160, and 200 is for S1, and so on for S2 and S3. Now the calculations are very simple. Probability multiplied by 140 plus 0.5 multiplied by 100 plus 0.1 multiplied by 80. This total gives me 114. Similarly, you do the calculation for A2 and A3. And you can mark the one which is the maximum. So the maximum EMV is 174. That means if I'm launching the product ozone, I should go for high expenditure, you can say advertising program. Okay, that is what it indicates. But which product should I launch? So again, I need to do the same calculation for the other product, that is life. So you can see this, the total, you can see the total expenditure because these values are given in thousands. 10,000, sorry. So I have to multiply this 174 with 10,000. So this value is coming to 17 lakhs 40,000. Okay. And the expected monetary value with perfect information will be, you can say 0.4. So take 0.4, multiply by the maximum here, 200 plus 0.5. Again, the maximum is in A3 here, 160. 0.1 multiplied by 140. Okay, that is again coming to 174. So there's hardly any difference between these two. So when we subtract this two values, your VPI is coming to 0. Okay, so value for or value of perfect information is 0. We do not require any information in a way, especially for ozone. Might be the same thing will happen in case of the other product as well. Let us see the calculation for the other product. Please note it down as soon as you see this. Again, you have I have rewritten the table here. Your strategies A1 to A3, your state of nature S1, S2, and S3. Now the probabilities have changed. So this is my other probabilities from the table 0.2, 0.2, and 0.6 for S1, S2, and S3 respectively. And we do the calculation, you find that 168 is the maximum. That means if I want to launch this product live, again, I have to go for high, you can say expenditure on advertisement. Again, you can do the calculation. This total will come to 16 lakhs 80,000 if you multiply this by 10,000. So multiply this by 10,000. The maximum expected payoff for life is 16 lakhs 80,000. Okay, you can do the calculation with expected monetary value with perfect information, that is EM VPI is equal to 0.2 multiplied by the maximum value in this, which is coming 230. So 230 multiplied by 0.2 plus 190, which is maximum in this 3, multiplied by 0.2 again. And even in this case, 140 multiplied by 0.6, which will come again, it will be the same 168. So VPI will be 0 again here. Now, if you compare the two EMV values for ozone, we had 174, and for life, we got 168. Okay, in of course in 10,000s. So that is 16 lakhs 80,000 in case of life, and 17 lakhs 40,000 in case of ozone. So comparing these two values, the maximum is 174 or 17 lakhs 40,000. So we should go ahead and launch or select the ozone product to be launched in the market, which will give me the maximum profit, you can say. So the conclusion would be, after comparing the two products, the maximum, as I said, is ozone. So you can see, write the statement. This can be written on, by your own, you can in your own language if you want. You can write it down. This is how I have written it. So ozone, which is having the maximum EM V, corresponds to the strategy A3. That means I should launch ozone, and the strategy which I should apply is E3, which is high expenditure on advertisement. Okay. Any doubts here?
No, sir.
Okay. Fine. Great. Now, yes. Anyone? Any doubts? Okay. In some cases, there's one more problem which I would like to take. I hope I have it. Yeah. I want you all to just try this out. Problem here. Say Suresh finds the probability of demand distribution of luxury car S as follows. Here we have probability of demand 0.2, 0.4, 0.1, and 0.3. The demand for car each day is 1, 2, 3, and 4, and the probability is given to you. Now, the selling price of the car is 10 lakhs, and its cost to Suresh is 6 lakhs. Okay, so the difference, if you say 10 minus 6, you'll give me 4 lakhs. So 4 lakhs is the profit if I sell a car. Suresh has always followed a rule for initial purchase. That means what he's doing is initially he's always purchasing three cars. Okay. Now find the expected daily profit under the decision rule of buying three cars each morning. The fees for perfect information is rupees 1 lakh. Calculate the expected monetary value of the venture with perfect information. Okay. So VBI is given to us. So there is 1 lakh. Okay. So depending on the calculation, we should always come up with a strategy whether we should go for or the strategy which Suresh is using right now. That is buying three cars every morning or each morning. Whether the strategy is giving him the best outcome or the best result. So that is what we are going to find out. Let us see the solution. Now, in this case, we are going to take some state of nature. So N1 we have considered as state that the demand is 1, N2 for demand 2, N3 and N4 respectively for demand 3 and demand 4. Okay. Strategies will be S1, S2, S3 and S4. So whether I should buy one car, buy two car, buy three car and buy four car. These are the strategies. Now we need to calculate the payoffs. Okay. If the time gets over, please, I want you all to join back and we'll solve this problem and then we'll stop. So for all my strategies, S1 will be buying one car, S2 will be strategy of buying two car, then three cars and the four cars. Okay. Now we have to find the conditional profit per day to Suresh for each strategy. So if you look at the formula which I'll be using, the payoff will be equal to the car sold multiplied by profit per car, and profit will be 4 lakhs, depending on the number of cars sold, that multiplied by the profit minus cars unsold multiplied by the cost. Cost is 10 lakhs, oh, sorry, 6 lakhs. Selling price is 10 lakhs. So cost is 6 lakhs. So if the whole formula, if I have to find out the payoff for S1, N1, number of cars sold is S1, buy is also 1, right? So I'm selling the same car. So this is 1 into bracket 10 minus 6, which is 4. And this will be, the cost is 6 lakhs. So multiply by 0. This will give me 4 lakhs. Similarly, I have to do the calculation for the other strategies as well. Now, when we, I think, please rejoin as soon as this meeting gets over. In fact, I'll stop this.